Okay, hi everyone. So we're gonna work on the projectile motion problem types right now. Mainly, we're gonna start on exam review 1, problem 8, the one that says on planet Beldar. I'm gonna be working on here. Reminder that these are the three equations that, again, if you're in my class, you will definitely have on the exam. Height, velocity, acceleration, where h is a t squared plus bt plus c, where a is the force due to acceleration, b is the initial velocity, c is the position, v, velocity, is 2at plus b. Note that these two are the same a and same b from our original equation in quadratic form, and then acceleration is 2a. So again, that means if acceleration was negative 32 feet per second squared, then that is 2a, so a is just negative 16, and that would be the value we use in the equation. We'll take a look at that in practice with the new value here as well. Okay, so original problem is on planet Beldar, a rock is thrown up into the air. Its velocity in feet per second, t seconds after it is thrown, can be found using the equation v is equal to 60 minus 12t. Answer the following questions as specifically as you can. Okay, so we know that v is equal to 60 minus 12t. Right, so that means that our starting velocity is 60, right? When t equals 0, v equals 60. And every second, for every increase in unit time, our velocity is dropping by 12, right? So let's just have a rough sketch of that, where this is velocity, this is time. We're starting at 60, and then just going down, right? This is a linear equation. My velocity is going down in a linear fashion. Okay. When is the velocity of the rock greatest? What is the greatest velocity? So clearly this is only decreasing while t is positive, right? We're only looking at positive times. So for a, our greatest acceleration, or I'm sorry, our greatest velocity is 60, are we in feet? Feet, sorry. 60 feet per second at t equals 0, right? That is what, and that makes sense, right? The only time we're putting force on the rock is when we throw it up in the air. After that, it should only be slowing down. Keeping in mind that speeding up towards the ground, meaning in the negative direction, counts as slowing down, right? The velocity is still decreasing. Okay, so 2, it asks when the height of the rock is the greatest. So, actually less complicated than you might initially think. The height of the rock, so we know from the quadratic equation here that the height of the rock will happen at its vertex. The greatest height will happen at the vertex, which will also be equal to negative b over 2a. I'm going to write that as a reminder. I don't need that back there. That our axis of symmetry happens at negative b over 2a. But that also, from our velocity graph, we can tell that it happens right there, right? And that's because if positive velocity is us going upwards and negative velocity is us coming downwards, then we keep going up and up and up and up and up until there, where we turn around and start dropping, right? So in other words, this x-intercept must be the when the height of our rock is the greatest, right? Because it's the last time it's still going upwards. So that means we're looking for essentially the x-intercept here. I guess in our case, t-intercept, right? So we want 0 is equal to 60 minus 12t. 12t equals 60. T equals 5. So that is when our height is the greatest, right? At 5, 0. So let's see. That's part of the problem. So for those of you who have lost your packets, suppose at 2 seconds the height of the rock is at 106 feet. What is the initial height of the rock, and what is the rock's maximum height? Okay, so let's do this. So that means basically we know we have the point 2, 106. Right, and now, whoops, we have 2, 106. But also let's check in on everything else that we should have. Okay. So we know generally not y, h equals at squared plus bt plus c. So here is, we should remember that in this standard form, this A is force due to gravity, so acceleration due to gravity. Remember that it's 1/2 the actual force, but let's just also look at how they're defined here. B is initial velocity and C is initial height. So we actually do know A because our velocity equation, we're looking generally at V is equal to -2at plus b. And we have V is equal to, I'm going to rewrite it in that order, -12t plus b. Right, so that means -12t must equal to at. So A is just equal to -6. Okay, so based on how this is defined, we know that little a is -6, which means our force due to gravity is -12 feet per second. But the value of a that we're using is -6, right? Because 2at is this value. So now that means we have h is equal to -6t squared plus bt plus c. Oh, and we know the initial velocity, right? We know the initial velocity is 60 from earlier. So now we actually have h is equal to -6t squared plus 60t plus c. And now we have this point 2, 106, which we know must satisfy this equation, for which we have every value except for c. Right, so plugging in values for both t and h will now give us a value for c. So it looks like 106 is equal to -6 times 2 squared plus 60 times 2 plus c. 106 equals -6 times 4, -24 plus 120 plus c. Correct. Yeah. Great. So now that is 130 minus 120 equals c. C equals 10. Great. So from all of that, we have h is equal to -6t squared plus 60t plus 10. Just to reiterate, that now means that our force due to acceleration on planet Beldar, or wherever we are, is -12 feet per second squared, but it's -6 in terms of coefficient. Again, you will be provided this definition here, so as long as you look at that, you can remember that this just needs to be half of the described force. Then our initial velocity was 60 feet per second when we threw the rock, and we threw the rock from a height of 10 feet. So that is what this equation means. Oh, so we answer initial height. I'm going to write hi is equal to 10. And we also want to know when the rock's maximum height is at. So if we remember from earlier, our axis of symmetry is at -b over 2a, right? So that's -60 over -12. So that will happen at 5. For those of you who are either not comfortable with using -b over 2a or don't know why that happens, if we had taken this same equation, factor out -6, and make it -6 times t squared minus 10t minus 10 over 6. This number doesn't matter, but from here you would see that the t squared minus 10t would mean that when we complete the square, it would become t minus 5 quantity squared, meaning our axis of symmetry would be at 5, the same place that is. So this negative b minus 2a, all we're doing is dividing out the a, and then taking this half of this b value to complete the square, right? So that's where the negative b over 2a comes from. Okay, so what do we do with this? Now we know that a maximum height happens at 5. And we have an equation, a full equation for height, right? So we just plugged it in. H is equal to negative 6 times 5 squared plus 60 times 5 plus 10 is equal to, what's that, 25, 6, 150, negative 150 plus 300 plus 10 equals 160. So 160 is our height at 5, which was our height at the max. So our maximum point happens at 5, 160, and we are done with part C. Is there more? There is more. Okay. From here, it asks for the other x-intercept, right? When does it hit the ground, meaning the other x-intercept? Honestly, from here, I would just plug this into the quadratic formula, just because this would be a harder square to complete than necessary. But if you want to complete the square, also totally okay. Quadratic formula, if we remember, is negative b plus or minus the square root of b squared minus 4ac over 2a. This comes from us completing the square of a generic standard form equation. If you want a refresher on why this is what it is, there's another YouTube video already up on it. But feel free to use it on the exam. Just remember that this doesn't really count for much in terms of showing your work, especially if you memorize the formula incorrectly. So, but either way, in the interest of time for now, I'm just going to plug into the quadratic formula. 900 minus 4 times negative 3 times 5 all over 2a. Oh, I'm sorry. I did one other thing. From here, I divided everything by 2 to give myself negative 3t squared plus 30t plus 5. So this is actually over negative 6. And I did this just because since they're the x-intercepts, we can just factor out constants and use smaller numbers. Granted, 3, 30, and 5 aren't exactly the best numbers to work with, but still smaller numbers than those because our x-intercepts are not affected by factors of a, right? And then I can tell you that this turns into roughly 10.17. Right, we care about this one, not the negative one, so it will fall to the ground at 10.17. And then in terms of graphing this, oh, I'm sorry, I did also want to point out one other thing. This whole negative b over 2a axis of symmetry where we found the max height, we already had this 5 from here earlier when we did part B. Okay, so my bad, I did some extra work. On a test it'd be totally okay to already say that you know this from part B and have plugged in 5 from here instead of using the negative b over 2a. Either way, the math still works. Last part was just graphing it. I trust you guys to be able to graph a y-intercept, a vertex, and x-intercepts and draw the line through. Yep, that's it.